These will be the last two graphs that we're going to graph, cosecant and secant. You should already know that cosecant is the reciprocal of sine. So cosecant equals 1 over sine x. So first let's write down some points for sine. Let's see, when x is equal to 0, y is equal to 0. Remember, it starts on the x-axis. And then when we get to pi over 4, we are at radical 2 over 2. When we get to pi over 2, we're at 1. Let's see, 3 pi over 4, we're at radical 2 over 2 again. And pi, we're going to be at, let's see, this is coming back down, so 0. And then we'll be at 5 pi over 4. And this should start being negative radical 2 over 2. And then this is 3 pi over 2, which is going to be at negative 1. So we've just graphed the points for a basic sine graph. If I do the reciprocal, I'm only going to make the reciprocal of y. So at 0, my x points are going to stay the same. So let's go ahead and fill those in. Okay, and now I'm going to take all my y values from sine, flip them over, put them in y values for cosecant, and we're going to see what happens. So when you flip 0 over, this is 0 over 1. You flip it over, you get 1 over 0, which is undefined. And like tangent, we're going to put an asymptote there. Okay, flip pi over 4 over, you're going to get 2 over radical 2. Flip 1 over, you still get 1. Flip that over, you get 2 over radical 2. Undefined, negative 2 over radical 2, and negative 1. So if I'm putting this on the graph, I know that at 0, you should realize we're going to have an asymptote. So I can draw that in here at 0. 2 over radical 2. Let's get the decimal for that. 1.4. So this is the equivalent of 1.4. So I know when I get to pi over 4, I need to be up a little bit above 1. At pi over 2, I need to be at 1. 3 pi over 4 above 1. And at pi, I'm going to have another asymptote. After pi, I'm going to be down below negative 1, at negative 1, below negative 1. So here's what the graph ends up looking like. They're parabolas, and essentially what they're doing is they're bouncing off of the sine graph. So if I were to go in here and sketch in my sine graph, that's what it would look like. And my asymptotes are everywhere there's an x-intercept. Everything else bounces off. So I'm going to bounce off in the low direction, and this one's going to have a high. Same thing over here. Secant is 1 over cosine. So if I do points for cosine, remember cosine is the bowl. At 0, I'm going to be at 1. Pi over 4, radical 2 over 2. Pi over 2, 0. 3 pi over 4, negative radical 2 over 2. Pi, be at negative 1. 5 pi over 4, negative radical 2 over 2, and 3 pi over 2. I'm going to be back at 0. So there's my cosine graph, and if I put that on here, this time since you know basically what it's going to look like, let's do fourths. So here's pi. And if I put cosine in, it's at 1. Oops. Let's see, I've got to hit my low point at pi, my high point at 0, halfway through. So that's how much I've got there. Going the other direction, it's over here. Okay, if I flip all my angles over, not my angles, my values, transfer the exact same angles, they're not changing. Okay, if I flip 1 over, what do you get? 1. 2 over radical 2, undefined. Negative 2 over radical 2, negative 1, negative 2 over radical 2, undefined. So I'm going to start 0 at 1, just like a normal cosine graph. But at pi over 4, I'm going to go above 1, and at pi over 2, I'm going to have an asymptote. Then at 3 pi over 4, I'm going to be at negative 1.4. Pi, I'm going to be at negative 1. 5 pi over 4, less than negative 1, and then another asymptote. Okay, so I know there's going to be an asymptote here because that's an x-intercept, an asymptote here because that's an x-intercept. And draw my parabolas in. So you can see how they are very closely related to sine and cosine. They bounce off of the maximums and the minimums. Here is a picture out of your textbook defining everything. Talk a little bit about the range. The range of cosecant is up and down. It covers everything from negative infinity up to negative 1. And then it skips up to 1 and goes on to positive infinity. Domain, the left and right. It's got these asymptotes and we have to cut them out. They're happening at every pi n, where n is any integer. Okay, it still has the same period of 2 pi. It does not have any x-intercepts. It does have vertical asymptotes on every pi. For the secant graph, domain, left and right, I've got these asymptotes and they're always on the half pies. So the 1/2 pi plus, and then they happen every pi later. So here's the first one, pi later, pi later, pi later. I'm going to land on another asymptote. Same with the range. My graph is covering everything up to negative 1, skips 1 to infinity. Y-intercept, it does cross at 0, 1. It does not, or the vertical asymptotes are happening on every half pi and then every pi later. When you start sketching these graphs, you want to actually sketch the reciprocal function. So we want to look at 2 sine of x plus pi over 4. Once we graphed that, then we can graph the reciprocal function. Okay, for this one, I know my a is equal to 2, b is equal to 1, which means my period is going to be 2 pi, c is equal to negative pi over 4, and so that means And since my b is 1 divided by b, but I'm going to be moving left, pi over 4. D is equal to 0. There's no vertical shift. Okay, so put this on the graph. I'm going to label these in quarter pi, so label pi and negative pi. My sine graph starts at 0. Period is 2 pi. I should have some more points on here. Starts at 0, crosses in the middle at 0, and it's back up at 0. This graph is going to go up and then down, so up to 2. So up to 2, down to negative 2, and that would be the first graph. But it has a shift. Everything is going to be shifted over 1 tick mark. So here are my new points. This one, this one, this one, this one, and this is my sine graph. Just continue it so we can get a bigger picture. Now that's not my final answer because the question asked you to graph cosecant. So that means now we go in, we draw some asymptotes at our x-intercepts. And we draw in the parabolas. Coming off a minimum, coming off of a maximum, coming off of a minimum. And that's it. Technically, the graph, if you were to look at it on a calculator or in the book, this middle line is not going to be there. But graphing by hand, which is the way we are doing it, you graph that first and then you can get your final graph. Okay, negative secant, which means I'm going to start by graphing negative cosine of pi x over 2. So my a is 1. It is flipped. B is pi over 2. So when I do 2 pi over 2, I'm going to get 4. C is 0, no horizontal shift. D is 0, no vertical shift. So graphing cosine on the graph. Let's see. Well, we'll just count by ones. There's 4. And negative 4. It's a flipped cosine, so it's the upside down bowl. I'm going to start at negative 1. It's got to end there. Maximum in the middle. So there's my cosine graph. Continue it so we can get a bigger picture. And then put in my asymptotes where my x-intercepts are. These are pretty tight together. Oops, that's not one. Okay, over one too far. And that one. And then we can draw in our parabolas. Okay, you try this one. Pick out your A, B, C, D. Reciprocal of cosecant is sine, so you're going to start by graphing sine. So give it a shot, press pause. Okay, here's what you should have got for your sine graph. You're going to put your asymptotes on the x-intercepts. So every 2 tick marks is an asymptote. And then we're going to draw in our parabolas. Okay, this one you're graphing a secant, so you're going to start by graphing a cosine. Get it started, come back, see if you got it right. Okay, here is the cosine graph I've put on here. Now let's draw in our asymptotes. There will be 2 tick marks on this graph. And draw in the parabolas. They do continue infinitely, so they do need arrows on them. There we go.